Welcome in. Today, we're going to take a deep dive into something pretty cool, the flyweight design pattern.
Yeah, it's a really interesting one.
Yeah, and it's super useful in software design. And
I think a lot of people have probably heard of it.
yeah, have you come across it much in your work?
Oh, absolutely. Especially with game development and things like that.
Right. Because I was thinking, like, how do games handle, like, hundreds of objects on the screen at once? Like, think about
It can be a nightmare if you're not careful.
exactly, like, if every tree or every enemy was, like, this whole big object, it would just be,
Yeah, your game would just grind to a halt.
That's where flyweight comes in, though, right?
Exactly. It's all about efficiency.
So how would you explain flyweight then? Like, what is it at its core?
Well, imagine you're building that game with all those trees. With Flyweight, instead of storing every single detail of each tree separately, like the shape of its leaves and every branch,
Hmm.
you'd have one kind of blueprint for a tree.
Okay, so like one generic tree blueprint.
And then you just adjust things like its position, how big it is, maybe a few other things for each instance.
So like you say, okay, this tree's going to be a little taller, put it over there.
Exactly.
And that saves you a ton of memory because you're not duplicating all that information for every single tree.
Exactly.
So instead of a memory hog, you've got like a lean, mean green coding machine.
That's a great way to put it. It's about making the most of your resources.
So how does this actually work in practice? Like, what's the magic behind flyweight?
Well, at its core, Flyweight is about efficiently sharing identical or very similar objects in your application. It's about figuring out which parts of an object are always the same. We call that the intrinsic state.
Okay, intrinsic state.
And separating those from the parts that change between instances, which is the extrinsic state.
Got it. So intrinsic is like the constant stuff, and extrinsic is the stuff that varies.
You've got it.
Okay, so going back to our tree example, would the intrinsic state be like the species, like oak, maple, that kind of thing?
Exactly. The species, the basic shape of the leaves, the texture of the bark, that's all intrinsic.
And the extrinsic state would be the stuff that makes each tree unique, right?
Precisely. So things like its exact location in the forest, how tall it is, maybe even how many branches it has.
Ooh, I see. So it's like, this is an oak tree, it's 20 feet tall, it's at these coordinates, and it's got this many branches.
Exactly. You're getting it.
This reminds me of that seesaw analogy I read about where one side is labeled RAM and
Oh, yeah. I like that one.
it's like on one side, you have tons of copies of the same object, which is all that intrinsic state.
Mhm.
And then on the other side, a single larger object represents the unique extrinsic state for each instance.
And by shifting the weight to the side with the shared intrinsic state, the flyweight pattern keeps your application's memory footprint in check.
That's a pretty cool visual. But how do we go from this seesaw to actual code? Like, how does that translate?
Yeah. Well, in practice, it comes down to how you design your classes. You see that shared, unchanging, intrinsic data that lives in your flyweight object, but the unique extrinsic data. We pass that around as parameters to the flyweight's methods.
Interesting. So it's like the flyweight object has a bunch of settings, and we just tweak those settings for each instance.
That's a good way to think about it. It keeps things very efficient. Now, I know the research mentioned 4 key parts to the flyweight pattern. Have you had a chance to look at those?
Yeah, and I have to admit, when I saw them all together like that, it seemed a little intimidating. Like there's the flyweight interface, the concrete flyweight, then the flyweight factory, and finally the client. That's a mouthful.
It sounds like a lot, but it's actually quite elegant when you break it down.
Well, I'm all ears. Break it down for me. What's the deal with all these flyweight characters?
Okay, let's start with the flyweight interface. Think of this as the blueprint for all our flyweight objects. It defines how concrete flyweights will receive and act upon that unique extrinsic state we talked about.
So it's like the rule book. Make sure everyone's on the same page.
Exactly. Now, for the concrete flyweight, this is where things get real. Here, we implement that flyweight interface and store all that intrinsic, unchanging state we discuss.
So if we're talking about our tree example again, this is where we define what makes an oak, or a maple, a maple.
Exactly. All those core characteristics.
And then we have the flyweight factory, which honestly sounds a bit like something out of Willy Wonka.
It does, doesn't it? But trust me, it plays a vital role. Think of this component as our organizational whiz, making sure we manage and share our flyweights efficiently.
So it's like a librarian for all our flyweight objects. Keeps everything tidy.
You got it. The flyweight factory makes sure that if we need 10 oak trees, we're not creating 10 separate objects from scratch. We're reusing what we can to keep things efficient.
Gotcha. And then last but not least, we have the client. What's their role in all this?
Ah, the client. This is the part of our code that interacts with all those flyweights. It holds references to them and manages that unique extrinsic state. Essentially, it's the director, calling the shots on how each flyweight will look or behave based on its specific attributes.
Okay, let's see if I've got this straight. Let's say we're building a video game, and it's got all these enemies running around. With Flyweight, we'd create a blueprint for each enemy type, let's say a goblin, using the concrete flyweight.
Precisely. You'd have a goblin concrete flyweight that defines all the common traits of a goblin.
Okay. And then for each goblin in our game, we just adjust the extrinsic stuff.
Exactly, like their position on the map, their health points, maybe what weapon they're carrying.
So we're not storing all that redundant data for every single goblin. That's pretty genius.
It's a very efficient way to handle things, especially when you're dealing with a lot of similar objects.
This is giving me all sorts of ideas. This pattern could be used for way more than just games, right?
Yeah, absolutely. Think about something like a word processor, for example,
Yeah, good point.
where you need to display a whole document with thousands of characters.
Each character is its own object, right? With fonts and sizes and colors and all that.
Exactly. And if you're not careful, that could eat up a ton of memory.
Oh yeah, for sure.
Yeah.
Imagine storing every single detail of every single letter. That's crazy.
That's where Flyweight comes in. Instead of storing the font definitions for each character, you store them just once.
Okay, so you have like a master font library.
Exactly. And then for each character instance, you simply say, okay, this one's going to be Times New Roman, 12 point, and red.
So instead of storing thousands of copies of the letter A in different sizes, you just store the design once and tell each instance how big it should be.
Precisely. Much more efficient, right?
Way more efficient. And I bet this comes up in all sorts of applications.
Oh, absolutely. Think about online stores with huge product catalogs. Each product has images, descriptions, reviews.
And they probably use Flyweight to keep things running smoothly.
You got it. They can store common product data like images just once and then reuse it across the entire site.
That makes a ton of sense. So we've got games, word processors, online stores. Is there anything Flyweight can't do?
Well, it's not magic, but it is a pretty versatile pattern.
It sounds like it.
Yeah.
The more we talk about it, the more I'm seeing how widely applicable this is. It's like you said earlier, it's about working smarter, not harder, right?
Exactly.
Speaking of working smarter, the notes mention something about a practical exercise, something about drawing shapes using Flyweight.
Ah, yes. A classic example. Imagine you're building a simple drawing app, right? Your Flyweight would be the shape class.
Okay, so the shape class is like our blueprint. It tells us how to draw a shape in general.
Exactly. It'd have all the logic for drawing different types of shapes.
But then how do we get specific shapes? Like how do we draw a circle versus a square?
That's where the concrete Flyweight classes come in. You'd have a circle class and a square class, each implementing that shape interface we talked about.
So the circle class knows how to draw a circle, but it gets the basic drawing logic from the shape class.
Exactly. No need to repeat ourselves.
I like it. Keep it DRY, as they say. Don't repeat yourself.
Exactly. And of course, we can't forget our Flyweight factory.
Right. Got to keep those shapes organized.
It'd be responsible for managing all those shape objects, making sure that if we're drawing 10 circles, we're only creating one circle object and reusing it 10 times.
And then our client, the part of the code where the user is interacting with the app, would tell the factory what kind of shape to draw and where to draw it.
You got it. Building something like this, even something as simple as a drawing app, can really help you understand how Flyweight optimizes memory usage.
It's a great way to see these concepts in action. And I think we've covered a lot of ground here. We talked about what Flyweight is, how it works. We looked at examples from video games to word processors to drawing apps.
It's a pretty versatile pattern, like we said.
It really is. But before we get too carried away, are there any downsides to using Flyweight? Is there ever a time when it's not the right tool for the job?
Well, like any tool, Flyweight does have its trade-offs.
Okay, so it's not all sunshine and roses now.
Not quite. It's not a magic bullet, and there are situations where it might actually make your code more complex.
So when you say complex, what should our listeners be wary of?
The main thing is that when you're sharing state between objects, it can be tricky to manage, especially as your application grows.
Because if one part of your code changes that shared state, it could mess things up for other parts of the code.
Exactly. You need to be very careful to avoid unintended consequences. Like, let's say you have multiple parts of your application using the same Flyweight object.
Okay.
If one part modifies the shared intrinsic state, it could have ripple effects you didn't anticipate in those other parts.
So it's like sharing a toy with a bunch of kids.
Yeah.
If one kid decides to, color on it,
Right.
the other kids might not be too happy about that.
Exactly. And in those situations, a different design pattern might be a better fit, or even just a different approach altogether.
So it's really about choosing the right tool for the job.
Couldn't have said it better myself.
Okay, so for our listeners out there who are thinking about using Flyweight in their own projects, what's the key takeaway here?
If you're running into performance issues because you have a ton of objects that share a lot of the same data,
Yeah.
that's a good sign that Flyweight might be worth exploring. It's like having a really well-organized workshop, right?
Okay, I like that analogy.
Everything has its place, and you can find what you need quickly and efficiently.
It's about working smarter, not harder.
That's it.
So to wrap things up, do you have any final thoughts for our listeners? Something to keep in mind as they dive into the world of Flyweight.
I'd say remember this. Flyweight isn't just about saving memory. It's about writing cleaner, more efficient, and ultimately more elegant code.
Because at the end of the day, who doesn't love elegant code?
Exactly.
Well, on that note, a huge thank you to you for taking the time to walk us through all of this today.
And it was my pleasure.
And to all our listeners out there, thank you for joining us for this deep dive into the Flyweight design pattern. We hope you learned a thing or two. Until next time, happy coding.